Okay, now that we are getting better at solving equations, now we're going to put two equations together and solve two equations at the same time. But not today. It'll take me a couple of days to teach that. Today we're just going to write the equations that go with this word problem. And there really are places out in real life where you do this. A business will track how much money they take in and how much their expenses are. Which one do they want to be more? How much money they're taking in or how much their expenses are? Don't they want to take up more money than they have to pay out for rent and electricity and stuff? If they don't make more money than their expenses, then the business is operating at a loss. And that has been one of the problems in the recent times, is a lot of businesses during this COVID time, have had trouble making enough money to pay their expenses. Okay, well, we're going to start off with a simpler problem than that. We're going to start off with this problem about Ashley's school selling tickets. And we're going to write the equations, and we're going to use variables. And either I have to tell you which variables to use, or you have to tell me which variables you're going to use. So in this particular problem, let's let the letter A stand for the adult tickets. That's reasonable, right? And so then we would let, what else? They're selling children tickets. And we are going to write two equations that goes with this word problem. Now, one of the things that people do wrong is they try to get all of this data in one equation. It's not all one equation. And so if you can access your highlighter tool, this part right here, I'm going to put in one equation. What happened on the first day? So, how many adult tickets did they sell? So, A stands for the adult tickets, so that's going to be 2A. How many child tickets did they sell? And when you add that up, you get a total of $104. Do you see how this mathematical sentence goes with the part that I highlighted? This part, the second day, is going to get me my second equation. So, how many adult tickets did they sell on the second day? How many child tickets did they sell on the second day? Oops. Was that correct? Was that supposed to be an A? What letter do I need with my 4? C for child tickets. And how much total money on the second day? Now, what's coming next is then we'll learn how to put those two equations together and actually find out how much money the adult ticket costs and how much money the child ticket costs. I'm going to give you a minute. So if we have a graph, we need to write the equations in y equals mx plus b form. So I'm going to do this line first. So y equals mx plus b. What does the b stand for?
Slope.
Nope. The b stands for the y-intercept. Yeah. What is the y-intercept on this problem? This one that I put in blue. And I skipped a space here because I'm going to go back and fill in the slope. And so when I count the slope, you have to count rise over run. I start at the bottom point and count up and over. How far did I go up? How far did I go over? And so then 1, 2, 1, 2, 3, 1, 2, 3, 4. Make sure you put the rise over the run, not the other way around. Now, look at that blue line. Is it supposed to be a positive slope or a negative slope? It is a positive slope, so that's the line that I have up here in blue. Now, what about this one in red? What is the y-intercept for this one? And so then I'm going to count the rise over the run. 1, 2, 3, 4, 5. 1, 2, 3, 4. Make sure you put the rise over the run. That's why I always count the rise first, so that I put the rise over the run. Now look at that red line. Is it a positive slope line or a negative slope line? And so what we will be learning is how to put the two equations together and come up with that intersection point. What are we going to do if we have tables? How are we going to write the equation if we have tables? Well, it would probably be easiest to write the tables in y equals mx plus b form. What does the b stand for again? Do you know how to tell a y-intercept from a table? If the x is 0, that's the y-intercept. If the x is 0, that's the y-intercept. They were nice enough to give us the y-intercept for these lines. So what else do we need? Are we getting better at using this formula? We put the y numbers on top. I'm going to choose to use these 2 points. It doesn't matter. You can use any 2 points on the table. I'm going to choose those 2. 7 minus 5, 2 minus 0. And so 7 minus 5 and 2 minus 0, and what's 2 over 2 equal to? So this is y equals 1x plus 5, because that's the y-intercept. Except when the slope is 1, we usually don't write the 1, because that's 1x. We can see 1x there. We don't really need the 1. For this table, I'm going to choose these points. And so I'm going to have negative 5 minus a minus 4, 3 minus 0. I would prefer you to be able to do that without a calculator, but if you need a calculator, use one. Minus a minus makes a plus. Negative 5 plus 4 would be negative 1 with a 3 on the bottom. So the second equation is going to be negative 1/3 x minus 4. This is the y-intercept. The y-intercept matches with an x number of 0. On this word problem, I gave you the variables that I want you to use. So Bill has quarters and dimes for a total of 15 coins in his piggy bank. He has $2.75. How many quarters and dimes does he have? What does X stand for? How much is a quarter worth? How much money? And so you would write that 0.25. X stands for the number of quarters. You'll multiply 25 cents times however many quarters he has. Y stands for dimes. How much is a dime worth? How much money does he have altogether? This is your money, money, money equation. Where do you get another equation, though? Well, what's the other number we hadn't used yet? We hadn't used the 15. 15 is the total coins he has. He only has 2 kinds of coins. What kind of coins does he have? X stands for the quarters. Y stands for the dime. Total means added up. The second equation is actually easier, but a lot of people get confused about the second equation. Now, I called it the second equation because I chose to write it second. Does the order of the equation make any difference? No. You should write your equation in standard form where the x comes first and then the y and then equal the number. Or, like our previous problem, y equals mx plus b form. But the order of the equations does not matter. So this is an equation about selling tickets. Now, once again, this is a real type equation because I was a ticket seller for the basketball game. And I had to make sure that the number of tickets I sold matched the amount of money that I had. Because I would get in trouble if they didn't match because someone would think I was stealing the money. And this is how you make sure that they match. So X is the number of adult tickets. How much does the adult ticket cost? So that's 5X. Y is the student ticket. How much does the student ticket cost? And that has to add up to the total number of money. 5 is money, 2 is money, 290 is money. Where do you get the other equation? Well, we only sold 2 kinds of tickets here. The adult tickets and the student tickets have to add up to get the total number of tickets sold.